Hello and welcome back to the Networking Fundamentals section of this course, where we're covering the foundations of Ethernet and Internet Protocol. In this video, we'll be covering network components. Specifically, we're going to discuss the role and function of routers, switches, and firewalls. But before we really get into the meat of the network components, first, I feel it's important that we cover the OSI model. Now, you may recall that I mentioned this in the previous video of being able to speak fluidly in our discussions with other network personnel and in our learnings about different items that occur at different layers of the OSI model. So, what is the OSI model? The OSI model is a communication function model for the OSI protocol suite. Now, the OSI protocol suite is not really in use anymore. This was back in a time when TCP over IP and OSI were the two main competitors for our networks, our wired networks. And TCP over IP ended up winning that battle. Think DVD and VHS, or DVD and Betamax, or HD DVD and Blu-ray for the more modern. That TCP over IP ended up winning. However, the OSI model here, as shown here, gives us an excellent way of describing different areas of our network. And network engineers generally care about layers 1 through 4 here. Anything above is just the application layer as far as we're concerned. But the transport network, data link, and physical layers are things that you should be very comfortable with conceptualizing the information here for troubleshooting and for communicating with other networking personnel. So let's take a look at the different protocol data units at these various layers. So in our first 4 layers, first down at the first layer, this is our physical layer. This is where our standards for RJ45 and 802.11 for wireless exist. The protocol data unit that we use here is the bit. RJ45 or Ethernet, category 5 and 6 Ethernet cables. These are used as our physical medium for transmitting individual bits. At the data link layer, or layer 2, this is where our Ethernet standard exists. The protocol data unit used for Ethernet is a frame. So our layer 2 protocol data unit is a frame. And at layer 2 is where we start having addressing, our source and destination layer 2 addressing. We also have addressing at the network layer, at layer 3. This is where our IP addresses exist. Some other protocols that exist or live in layer 3 are ICMP, that is your ping, or OSPF, a dynamic routing protocol. The protocol data unit that describes a layer 3 unit of information is a packet. So recap, right? At layer 1, we talk about the transmission of individual bits. At layer 2, our unit of information is a frame. And at layer 3, our unit of information is a packet. And the last layer that we as network engineers really care about is layer 4, the transport layer. At layer 4 is where we have TCP and UDP protocols. That the data unit, or the unit of information at this layer, is a segment or a datagram. It's actually different given which protocol that you're using. We have TCP segments and UDP datagrams. We'll talk more about that when we talk about connection-oriented versus connectionless protocols a little later in this section. So the OSI model can really be described more in some troubleshooting aspects, where we talk about a layer 2 issue. That would be a MAC address issue or a broadcast domain problem. A layer 1 problem is a physical issue. If we have a problem where our port on our switch is not coming up, then we have a layer 1 problem. It is not negotiating the physical aspects of that port. Whereas a layer 3 issue would likely be a routing problem of some kind for our IP addresses. And a layer 4 issue would usually be more at the application layer. Our networking devices, our switches, our routers, don't really care so much about layer 4, except in terms of network address translation and firewalls, but we'll talk more about that later. It is very important to become comfortable speaking in terms of OSI model layers, of talking to your colleagues about your layer 2 address or about a layer 3 trouble that you're having. These are words and phrases that you would commonly hear of networking teams talking, and will be really important for you to be able to understand what they're saying and then also to communicate in their same language back. Now that we've taken a look at the OSI model, let's talk about some networking devices. First up are layer 2 switches. As discussed in the first video of this course, we had talked a bit about how a switch separates collision domains into one collision domain per port. A switch's primary job, the one thing that it gets up in the morning and this is what it does, is it learns which MAC addresses, that is our layer 2 addresses, live on which port. That it needs to know that MAC address 1 lives on this port, MAC address 7 lives on this port, and MAC address 10 lives on this port. We'll talk more about the format of MAC addresses in a later video, but any frame that the layer 2 switch receives, if it has a destination MAC address of MAC address 1, it should be forwarding out this port. And MAC address 10 should be forwarding out this port. This is so our connected devices do not receive unnecessary traffic, that only traffic that is destined to them will be forwarded out that port. As implied by a layer 2 switch, is that these switches only interact with traffic up to layer 2 of the OSI model. That would be our MAC addresses. Also included in our layer 2 header are some other items like a VLAN tag or class of service, but we'll get into that more later. Layer 2 switches only interact with our traffic up to layer 2, and they're primarily used for end devices to connect into the network. As we see here in our diagram, we have a switch that connects multiple end devices into the network and also to a router. We do have our hub. Hubs are largely not used anymore. Switches have become very cheap, and hubs are very inefficient, only allowing for half-duplex communication when more than 1 or 2 devices are connected. Whereas switches separate each port into its own collision domain and will generally connect multiple ports into a single broadcast domain, allowing for more flexibility and much more efficient communication. That's a layer 2 switch. Now let's talk about a layer 3 switch. As you might be able to guess, a layer 3 switch interacts with traffic up to layer 3 of the OSI model. That would be our IP addressing, our layer 3 addressing. These switches are the same as layer 2 switches. Every port is its own collision domain, and generally these switches will also have the ability for multiple broadcast domains. However, they will also have the ability for IP routing, and that's to interact with our traffic up to layer 3. Now you might be thinking, well, what's the difference then between a layer 3 switch and a router? And the answer is not much. However, layer 3 switches are typically not as full-featured as routers. They generally are more geared towards very fast switching of traffic between ports and forwarding of information, as opposed to more CPU or memory intensive tasks such as filtering or NATing or acting as an application layer gateway of some sort. Usually these switches are used as upstream switches or core switches for inter-VLAN routing and policies. If I have multiple broadcast domains within my network and I need to route between them, I could use my core switch, which would be a layer 3 switch, to route between those broadcast domains and also implement some basic filtering policies between them. As I mentioned, they're just not as full-featured as our routers. So speaking of routers, let's talk a bit about that. Generally, routers are better at interacting with traffic at layers 3 and 4. Usually it has far fewer ports than switches. For example, this router here, a Juniper SRX 345. This is a very nice router with multiple gigabits of throughput capability, and as you can see here, it has 4 SFP ports and 8 built-in gigabit RJ45 ports. This does have significantly fewer ports than our 48-port EX4300 switch here. However, this router is much more capable at CPU-intensive services, things like quality of service or application layer gateway and things of that sort. This is typically an edge device, something that connects your enterprise to the WAN or to your internet provider, or could be in between different branch offices. This actually falls under the category of a branch office router. The Juniper SRX 345 does. Excellent. I hope that this has given you a good overview of the network devices that we would commonly see in our enterprise. I hope that this has been informative for you, and I'd like to thank you for viewing.